Okay, let's finish going through these examples. And if you are just checking this video out, this is the second half of the 3.5 video. And we are verifying identities. So we're trying to make the left and the right-hand sides of our equation match each other. So it's open. There's so many different ways that you can do these problems. That's why some of you have already been asking me. There's not a key posted because you may not get the exact same thing or do it the same way that I did, nor the person next to you, okay? But some more suggestions. When I look at this example, my gut first was like, oh, I should distribute and get rid of those parentheses. But after pausing and looking a little closer, I see tangent squared plus 1. Well, I have an identity that says 1 plus tangent squared is equal to secant squared. So I'm going to plug secant squared in place of tangent squared plus 1. Times. All right, well, let's check this one. Cosine squared minus 1, is that an identity? Well, it itself is not. However, I do have an identity with sine squared plus cosine squared equals 1. So this says that it needs me to have cosine squared minus 1, so I don't have to subtract the 1. Okay, but now I still have the sine squared, so then what if I subtract the sine squared over to the other side? That gives me cosine squared minus 1 is equal to negative sine squared. So I can plug that in. Okay. So I had to know two different identities to get here, but this is one possible way to have done this problem. Now if I multiply that, I get negative secant squared sine squared. Okay, well, I know that secant is 1 over cosine, so let's see what that'll do. But since secant is squared, think about it as like squaring each side. So this would be negative 1 over cosine squared, still times my sine squared. Fractions, I multiply straight across the top. And isn't there an identity that says that sine over cosine is equal to tangent, but if I square both sides, that would give me sine squared cosine squared. So this here would be tangent squared, but then I've got my negative. And is that where I wanted to go? Okay, and take this the way however you want it. You might think that this is just me being very arrogant, hateful, or whatnot, but I'm going to work this problem a totally different way. I just want to prove to you and make a point of why I'm not posting an answer key, okay? What if I didn't see those identities and instead I distributed, okay? Oops, sorry. So I would have tangent squared x cosine squared x minus tangent squared x plus cosine squared x minus 1 if I distributed, okay? So now I'm going to start manipulating this down here. Ooh, kind of yucky. Ooh, okay. I see this thing, and they have a tangent squared in common. So I'm going to take a tangent squared out, which then would leave me cosine squared minus 1. And then I still have all this business plus cosine squared minus 1. All right. There's identities, and I've already used it once. Okay, so I'm not going to rework all of it again. It was up here. Okay, so I know that this is equal to negative sine squared times that tangent squared. And then I still have my plus cosine squared minus 1. Oh, wait a minute. Hey, there's another one of those. Let me back up. Actually, here, I'll do this. Hey, look, we just did this identity. We said that cosine squared minus 1 was equal to sine squared. Now I've got tangent squared times. Is that going to help me? Well, let's just try it. Plus negative sine squared. Okay. All right, so now, hey, they share a negative sine squared. So let's factor that out. If I take out a negative sine squared, I would be left with tangent squared plus 1. Ooh, that's an identity. We've already used it too. That was way up here. That's secant squared. So now I have negative sine squared x times secant squared. Oh, look, I kind of got back to the same boat I did up here. Secant squared is 1 over cosine squared. Which then gives me negative sine squared over cosine squared, which is negative tangent squared. Went a totally different route. Did I still end up at the same end result? Yes, I did. Okay. Again, that's coming off very abrasive, but notice, like, if you even paid attention to me talking, I hit a point when I said, oh, I don't know what to do. Well, let's just try this. That's the mentality that you have to get into when you're working with these identities of there's no set rule for what to do. You just have to try something, okay? And that's very difficult for some of you, and I get that, okay? But if you don't try something, well, then heck no, you're not going to get the right answer because you haven't even tried anything, okay? Oh, those are not. Okay. So now, either one of these, I will work. I'm not going to work both of them because I don't want this video to be too long, but I will work this one here. Just because this one I think will help a little bit with problems on your homework more. So pick a side to work on. I'm going to work on this side for just a minute. Okay. Notice my answer has all sine in it. So that's the first thing I'm going to do is I'm going to take cotangent and I'm going to turn it into a different identity that maybe has a sine, and same with cosecant. Yes, I'm going to make this look uglier first before I make it look better. So cotangent is cosine over sine. But since I have cotangent squared, I'm going to make this cosine squared over sine squared. All over 1 plus, well, cosecant is 1 over sine. Okay, so I'm going to turn that into 1 over sine. Now, here's where, in class, and probably you guys at home, this is where people are hitting a roadblock and they're like, I don't know what to do. Well, this denominator, something plus a fraction. Well, for one, we don't want fractions in a fraction anyways. I have to bring those terms together first. So what I'm going to do is I'm going to get a common denominator between these two terms and add them. Okay, so again, back up to the line in purple. I put the constant of 1 over 1. I turned it into a fraction, and I got common denominators. That's where I got my answer in red. Now that my denominator has fractions with common denominators, I added them together. That's how I got to where I'm at in blue. Now, I have a fraction divided by a fraction. We don't divide fractions. Instead, we multiply by the reciprocal. Okay, so now, look what I've accomplished is I have gotten to the point where I have, here, I'm going to come right over here. Okay, now I have cosine squared x times sine x over, when I multiply straight across, I'm just going to leave this in parentheses for a moment, sine squared x times sine x plus 1. This is a good thing because now look, I can cancel this sign with one of these. Okay. Well, we're getting a little bit better. Okay, we at least have signs in our problem. Well, let's figure out, is there something that we can do to get rid of the word cosine squared? Okay, so let's see. I know that cosine is equal to 1 over secant, but that doesn't do me any good. That just brings in another trig function that I don't want. I want all sines. Oh, I have this guy, that cosine squared plus sine squared is equal to 1. If I subtract the sine squared over, I have that cosine squared is equal to 1 minus sine squared. And then I can plug that in. That might, let's see what that'll do. Okay, I'm at least to all sines. That's a good thing because that's where my end result is at. We want nothing but sines. Okay. Now, this one not everybody may see. That's a difference of squares. Because what squared makes 1 and what squared makes sine squared. So 1 minus sine squared, can I factor that into 1 minus sine and 1 plus sine? And that's a great thing because now look, I have a 1 plus sine, and if I rewrote that to 1 plus, like they match, so those would cancel, leaving me with 1 minus sine of x over sine of x, which is what I wanted. Or theta, I shouldn't have switched my variable, sorry. Okay, now, mind you, that's the way I just worked that right now. That's not the way any of my students worked it that were seated in class, okay? Try something. I intentionally worked it a different way because I wanted you to hear me set and say, let's try this. And, oh, I don't know what to do. Like, you need to hear that to understand that it's okay if you get stuck. Hopefully you listened to me and I just kept saying, okay, I need signs. Let's try something that's got a sign in it. Let's switch things out, switch things out, switch things out. The biggest issue that everybody in class is having, though, is this idea with the fractions. And I know you cannot see that yellow. This idea with the fractions. Getting your common denominators and putting things together will make many of the problems that are on your homework simplify down to identities that will give you the end result, okay? But if you are getting stuck on things, send me a picture of the question that you're on, where you're stuck at, and I will either write on it, like what I do with these notes, and give you a hint of, hey, try this. Or I'll send you an email that says, try getting common denominators or something. Like if you email me, I will help you through these.